So let us talk about artificial intelligence today. Artificial intelligence is the intelligence of machines and the branch of computer science that aims to create it. So AI textbooks define the field as the study and design of intelligent agents. So if somebody asks what is artificial intelligence, it is the study and design of intelligent agents, where an intelligent agent is a system that perceives its environment and takes action that maximize its chances of success. Now, artificial intelligence is the intelligence exhibited by machines or softwares. It is also the name of the academic field of study which studies how to create computers and computer software that are capable of intelligent behavior. So machines which are capable of intelligent behavior, that is why we call it as artificial intelligence. So major AI researchers, AI is for artificial intelligence, major AI researchers and textbooks defines the field as the study and design of intelligent agents I just mentioned, in which this intelligent agent perceives the environment and actions. This we have already discussed. Now, John McCarthy, who coined the term in 1955, defines it as the science and engineering of making intelligent machines. This is what is all about AI. A simple definition: science and engineering of making intelligent machines. What are the problems deduced through AI? They are numerous. Let us see few of them. Deduction, reasoning, problem solving, say motion and manipulation, and you have natural language processing, social intelligence. These are few problems which can be deduced through your artificial intelligence. Now, what are the approaches which are being taken under AI science? Few of them. These are the approaches which generally scientists and researchers take: cybernetics and brain simulation, symbolic, sub-symbolic, statistical, integrating. The approaches means few approaches can be combined or integrated. So let us start with cybernetics and brain simulation. So in 40s and 50s, a number of researchers explored the connection between neurology, information theory, and cybernetics. Some of them built machines that use electronic networks to exhibit rudimentary intelligence, such as Walter's Turtle and Johns Hopkins Beast. And many of these researchers gathered the meetings of Teleological Society at Princeton University and Ratio Club in England. So by 1960, this approach was largely abandoned. That is why we don't generally talk about this, although elements of it would be revived in the 1980s. In this era, it was abandoned, but again it took off after 1980s. Then came symbolic. So when access to digital computer became possible in 1950s, AI research began to explore the possibility that human intelligence could be reduced to symbol manipulation. Just symbol manipulation can give rise to human intelligence. So the research was centered in three institutions: Carnegie Mellon University, Stanford, and MIT, and each one developed its own style of research. So John named these approaches to AI good old-fashioned AI, GoFi. Good old-fashioned AI, GoFi. So during the 1960s, symbolic approaches had achieved great success at simulating high-level thinking in small demonstration programs. But approaches based on cybernetics, we just talked about it, or neural networks, were abandoned and pushed into the background. Researchers in the 1960s and 70s were convinced that symbolic approaches would eventually succeed in creating a machine with artificial general intelligence, and considered this the goal of their field. Then came cognitive simulation. Economists Herbert and Allen studied human problem-solving skill and attempt to formalize them, and their work laid the foundation of field of artificial intelligence as well as cognitive science, operation research, we call it OR, and management science. So their research team used the result of physiological or psychological experiment to develop programs that simulated the techniques that people use to solve problems. So this tradition centered at CM University, Carnegie Mellon University, would eventually culminate in the development of SOAR architecture in the middle of 1980s. This is very important architecture. Then came logic-based. Unlike Newell and Simon, John McCarthy felt that machine did not need to simulate human thought, but should instead try to find the essence of abstract reasoning and problem solving, regardless of whether people use the same algorithms or not. So his lab at Stanford focused on using formal logic to solve a wide variety of problems, including knowledge representation, planning, and learning. So logic was this, because we call it as logic-based. Logic was also the focus of work at the University of Edinburgh and elsewhere in Europe, which led to the development of programming language Prolog and the science of logic programming. This Prolog and logic programming. Then anti-logic or Scruffy. Researchers at MIT, such as Marvin and Simmer, found that solving difficult problems in vision and natural language processing required ad hoc solutions. So they argued that there was no simple and general principle like logic we just talked about that would capture all the aspects of intelligent behavior. So Roger described their anti-logic approach as Scruffy, as opposed to the neat paradigms at CM University and Stanford. So common sense knowledge bases such as Dr. Leonard Sick are an example of Scruffy AI. The Scruffy AI, since they must be built by hand, one complicated concept at a time. Then came knowledge-based. When computers with large memories becomes available at around 1970, these researchers from all three traditions began to build knowledge into AI applications. So this knowledge revolution led to the development and deployment of expert systems introduced by Edward, the first truly successful form of AI software. Now we have knowledge revolution, the first successful form of AI software, and the knowledge revolution was also driven by the realization that enormous amounts of knowledge would be required by many simple AI applications. Then sub-symbolic, this is also one of the approach. So by the 1980s, progress in symbolic AI seemed to stall, and many believed that symbolic systems would never be able to imitate all the processes of human cognition, especially perception, robotics, learning, and pattern recognition. So a number of researchers begin to look into sub-symbolic approaches to specific AI problems. Then bottom-up, embodied, situated, behavior-based, or novel AI. So researchers from the related field of robotics, such as Rodney, rejected symbolic AI. He altogether rejected this earlier approach and focused on basic engineering problems that would allow robots to move and survive. So their work revived the non-symbolic viewpoint of the early cybernetics researchers of the 1950s and reintroduced the use of control theory in AI, which were amended or which were thought that it will not be working in this particular field. So this coincided with the development of embodied mind theses in the related field of cognitive science. The idea that aspects of the body such as movement, perception, and visualization are required for higher intelligence. Then computation intelligence and soft computing. Interest in neural networks and connectionism was revived by David and others in middle 1980s. So neural networks are an example of soft computing. There are various stuff or approaches which are involved in soft computing. So they are solutions to problems which cannot be solved with complete logical certainty, because we don't think logically. We have 0 and 1 and in between also, not just 0 and 1 as machines think. So but an approximate solution is often enough. So other soft computing approaches to AI include fuzzy systems, evolutionary computation, and many statistical tools. So the application of soft computing to AI is studied collectively by the emerging discipline of computational intelligence. There's statistical. This is also one of the approach. In 1990s, AI researchers developed sophisticated mathematical tools to solve specific subproblems. So these tools are truly scientific in the sense that their results are both measurable and verifiable, and they have been responsible for many of AI's recent successes. So the shared mathematical language has also permitted a high level of collaboration with more established field like mathematics, economics, or OR. So Stuart and Peter describe this movement as nothing less than a revolution and the victory of needs. Then integration of the approaches. There are various approaches we just talked about. People tried integrating them also. So an intelligent agent is a system that perceives the environment and takes action that maximizes the chances of success. This is what we want. This is the definition of AI also. So the simplest intelligent agents are programs that solve specific problems. More complicated agents include human beings and organizations of human beings, such as firms. So the paradigm gives researchers license to study isolated problems and find solutions that are both verifiable and useful without agreeing on one single approach. So an agent that solves a specific problem can use any approaches that work. Some agents are symbolic and logical, some are symbolic neural networks, and others may use new approaches. So a combination of various approaches can be adopted to actually get to a AI which we thought in our definition. Then agent architectures and cognitive architecture. Researchers have designed systems to build intelligent systems out of interacting intelligent agent in a multi-agent system. A system with both symbolic and sub-symbolic components is a hybrid intelligence system. And the study of such system is artificial intelligence system integration. So a hierarchical control system provides a bridge between sub-symbolic AI at its lowest, reactive levels, and traditional symbolic AI at its highest level. Sub-symbolic AI at lowest and reactive levels and traditional symbolic at highest level, where relaxed time constraint permit planning and world modeling. So Rodney as sub-assumption architecture was an early proposal for such a hierarchical system. There are various tools also as far as this AI is concerned, like search, optimization, logic, probabilistic classifying, and neural networks, deep neural networks, control theory, and logics, which we just mentioned everywhere when we were talking about approaches. So let us see them also, the tools. First is search and optimization. So many problems in AI can be solved in theory by intelligently searching through many possible solutions, like reasoning can be reduced to conformist search. For example, logic proof can be viewed as searching for a path that leads from premises to conclusions, where each step is the application of an inference rule. So planning algorithm search through trees of goals and sub-goals, attempting to find a path to a target goal, a process called means end analysis. So robotics algorithms for moving limbs and grasping objects use local searches in configuration space. So a very different kind of search came to prominence in 1990s based on the mathematical theory of optimization. This is what we are talking about, optimization. So this algorithm can be visualized as blind hill climbing. We begin the search at a random point on the landscape, and then by jumps or steps we keep moving guess uphill until we reach the top. So other optimization algorithms are simulated annealing, beam search, random optimization. Then the other tool is logic. Logic is used for knowledge representation and problem solving. So knowledge representation, but it can be applied to other problems as well. Several different forms of logics are used in AI research. So propositional and sentential logic is the logic of statements that can be true or false. And first order logic allows the use of quantifiers and predicates and can express facts about objects, their properties, and their relation with one another, each other. Fuzzy logic is a version of first order logic, this logic, which allows the truth of statements to be represented as a value between 0 and 1. This is how we think. We don't think it's just simply 0 or 1. So default logics, non-monotonic logics, and circumscription are forms of logic designed to help with the default reasoning and the qualification problem. So several extensions of logic have been designed to handle specific domains of knowledge such as description logic, situation calculus, event calculus, fluent calculus for representing event and time. So causal calculus, belief calculus, and modal logics are also there. Then the other tool is probabilistic method for uncertain reasoning. So many problems in AI like reasoning, planning, and learning, perception, and robotics require the agent to operate in complete and uncertain information. The information is not available. the device has to think by itself. So Bayesian networks are very general tool that can be used for a large number of problems, reasoning, say planning or perception. So probabilistic algorithm can also be used for filtering, prediction, smoothing, and finding explanations for streams of data, helping perception system to analyze processes that occur over time. Then classifiers and statistical learning methods. Simple AI applications can be divided into two types, like classifier, if shiny then diamonds, for example, and the controllers, if shiny then pick up. So controllers do, however, also classify conditions before inferring actions. Therefore, classification forms a central part of many AI systems. Classifiers are functions that use pattern matching to determine a closest match. So in supervised learning, each pattern belongs to a certain predefined class. There is a predefined class, and only to which this pattern belongs. So a class can be seen as a decision that has to be made. So a classifier can be trained in various ways. There are many statistical and machine learning approaches. The most widely used classifier are the neural network kernel approaches such as the SVM, support vector machine, k-nearest neighbor algorithm, Gaussian mixture model, naive Bayes classifier, and decision tree. The neural networks, we talked about it a lot. A neural network is actually an interconnected group of nodes akin to the vast network of neurons in the human brain. So the study of artificial neural network began in the decade before the field of AI research was actually found in the work from Walter and Warren. So other important early researchers were Frank, who invented the perceptron, and Paul, who developed the backpropagation algorithm. This is very important as far as neural networks are concerned. So the main categories of networks are acyclic or feed-forward neural networks. That means only one direction, and recurrent neural networks, which allow feedback. So neural networks can be applied to the problem of intelligent control for robotics or learning using such techniques as heavier learning and competitive learning. So hierarchical temporal memory is an approach that models some of the structural and algorithmic properties of neurocortex. This is how neural things work. Then going to deep neural network. A deep neural network is an artificial neural network with multiple hidden layers of units between the input and output layers. Similar to shallow artificial neural networks, deep neural networks can model complex non-linear relationships. So over the last few years, advances in both machine learning algorithms and computer hardware have led to more efficient methods for training deep neural networks that contain many layers of non-linear hidden units at a very large output layer. Then control theory. Control theory, the grandchild of cybernetics, has many important applications, especially in robotics. In languages, AI researchers have developed several specialized languages for AI. Lisp, Prolog are one of them, or few of them. So what are the advantages of AI? AI would not need any sleep, exactly. A human being can sleep, and unemotional consideration of problem, easier copying, all these are the advantages, but there are certain disadvantages also. That is limited sensory input, artificial mind is limited capable to talk, and applications involved, there are numerous applications. I just wanted to highlight some of them, like gesture recognition, gesture and individual voice recognition, global voice recognition, facial expression recognition for interpretation of emotion and non-verbal cues, and robot navigation. So what I'm saying is that robotics is just not one size, or artificial intelligence is just not one size. There are various things, various science which are talking together, which are cooperating together, which are being integrated and working together to actually make a machine just work like a human being. So hope you got the idea